recording. Very sorry, we'll start again. My name is Seda Seth, and I'm a third year research scholar at IIT Roorkee. I am working in the field of geoenvironmental engineering, and I am a PMRF scholar. And this, I am one of the TAs for this course for you. As per PMRF scheme, there is a mandatory uh, requirement for us for TA-ship. It's less mandatory, more voluntary. So I will be I think there is one more TA attached in this course, and I will be so okay. Since there are not many students here, we can introduce. You can introduce yourselves. Yes, Vanita, where are you from? Where are you studying, and how did you
My
come up?
name is Vanita. I am from Vishakhapatnam.
Hmm.
My background is mathematics, MSc Mathematics.
Okay,
So I interested in civil geotechnical engineering.
okay,
So that's why I like.
that's very good. And Shubham, Shubham, can you hear me now?
Ma'am, good evening to all of you. I am from Maharashtra and currently I am pursuing my BTech third year.
Okay, okay. Thank you very much. Okay, so let us start with the session now. If you have any doubts, you can ask me during the session also, and there is also a discussion forum. You can ask your questions there also. And I will start projecting my screen. Okay, so I am projecting my screen. I hope you can see my screen. So, okay. We will be discussing in these sessions, we will be doing some questions that may help you with the assignments or general overall with understanding the course. And if you want, we can go over the assignments in this, the first interactive session. We can either go over to the assignment 0 and solve it, because that assignment does not contribute to the marking of for this course. The marking will start from assignment 1, and that is why those assignments I will not be discussing in only if somebody requests the discussion of any question in any assignment, and after the deadline of submission we can discuss those questions. Right now, at my hand, I have assignment 0, and there are some more questions based on the first week lectures. The first week lectures is just a review of soil mechanics, which is the origin, classification, weight, volume relationship, effective stresses, shear strength, and compressibility. So these are generally the topics that have been covered in the week 1. So there are some questions I will be discussing for these, and at the end, if there is some time left, or if you want, we can discuss the assignment 0 also, which is also a recap to soil mechanics. Okay, so let us move on to the questions. Uh, just a second. I was actually starting the one second. Okay. So in these sessions, I would like everybody to be as interactive as possible, because it will increase interest in the sessions and also make the sessions more fun. So the first question, as you can see, is the moist. Yes. Uh,
The most weight of
okay. Okay. The moist weight of 28.3 into 10 to power minus 4 meter cube of soil is 54.27 Newton. If the moisture content is 12% and the specific gravity of the soil is 2.72, we have to find the dry unit weight of the soil and the void ratio of the soil sample. We have been asked to take the weight of water 9.81 kilonewton per meter cube. So this is a very basic question from geomechanics or soil mechanics. You can anybody wants to contribute on how we can do this question? Or what we can do is you can solve it at your own on your own and then discuss the solution with me. Okay. Uh, the participants are on mute. If you wish to speak, you can unmute yourself. One second. If you wish to speak, you can unmute yourself. Mm, I will give, yeah, I will wait for 1 minute, and if you have something to contribute, we can discuss. Okay, so question number one. As we can see, this part, this part is the volume given to us, volume of soil. Do you want to try yourself? Yes or no, or a message? Any prompt from the participants? Uh, Vanita, I can't hear you.
Hello.
Yes, yes, Vanita. So you
Okay.
want to try yourself and then we can
Yes,
discuss the
ma'am.
solution,
I,
or do you want me to go on with the solution?
okay, ma'am.
Huh?
O- o- okay, ma'am.
Should
Go
I
ahead.
go on with the solution, or do you want to give it a try first? Okay, for the first question, let us solve it
I
first of all.
solved, ma'am, already. Uh,
Okay. Yes, what
I
is the answer?
understood the question. Okay.
So, what is the
Uh,
answer that you got?
wait a minute, ma'am. Calcium. Newton per meter cube. 54. One dry unit weight is the 1.71 Newton per meter cube.
Yes. And how did you come up with the solution?
Where gamma D is equals to gamma by 1 plus W.
Yes,
Gamma D is equals to gamma by 1 plus
W. Yes, yes, yes. That
where
is.
gamma is equals to 54.27 by
Yes, yes, yes.
28.3 something
Yes, yes.
calculation.
Yes, yes, yes. Exactly. So for the solution, uh, so the discussion that we are having, this will be available on this a channel on YouTube for streaming of for people that are not present in the session. So I will go on and discuss the whole solution. But you are correct. This is the approach and this is the answer. So let us. I will go on with the solution. So the volume of soil that is mentioned is 28.3 into 10 to power minus 4, and the weight, bulk weight, is 54.27 Newton. And as we know, the bulk density is equivalent to total weight divided by total volume, which will be equivalent to 54.27 divided by 28.3 into 10 to power minus 4. But here this is in Newton. So let us change this into kilonewton. This will be kilonewton per meter cube. And on calculation, we will get 4.27 divided by 8.3. We will get 1.91. I'll write it here. Gamma bulk is equivalent to 1.918 kilonewton per meter cube. Okay. And as you rightly said, that gamma D equals gamma divided by 1 plus W. So gamma dry will be equivalent to 1.918 divided by 1 plus 12%, 0.12. So this will come out to be gamma D equals 1.918 divided by 1.12, 1.7125, 1.7125 kilonewton per meter cube. Let us round up to two figures, and let me write this in another color. So the solution to the first problem, first part, is gamma dry equals 1.71 kilonewton per meter cube. So this is a solution for part 1.
Ma'am,
Okay. Yes.
Newton per meter cube.
No, I have changed kilonewton here, na? One second. Okay. I introduced this, na? This was in Newton. I multiplied it by 10 to power minus 3 here to change it into kilonewton. Yes?
Yes, yes, ma'am.
Is that okay?
Okay, 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 ma'am.
Okay. Thank you.
Into
Thank
10, 17.1, 54.27 divided by
It will be
20.
okay. Okay. I'm doing a mistake here.
Ma'am,
Here. I'm doing a mistake. Thank you. Thank you very much. Thank
ma'am,
you for pointing it out. This is
7,
19.18 and this is
17.1 kilometer per meter cube.
17 point. Yes. 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 Yes.
One.
Yes. Yes. So this is the general range of densities in kilonewton per meter cube part. If it was in gram per cc, it would have been 1.92 gram per cc. So, okay, I did a mistake there. Thank you very much. Thank you very much for pointing it out. Okay,
Yes,
uh, so let us move on to the next question.
okay, ma'am.
To the second part of the question, void ratio. Have you calculated the void ratio?
Yes. No, no, ma'am.
How
Point
do you
13.
think we should calculate the void ratio?
Okay, ma'am.
Any suggestion? Any hint from the question?
Where gamma is equals to gamma W into G plus E into SR by 1 plus E.
Yes, yes, yes.
Where
That
E into SR equals to W into G. So E plus E into SR is equals to W into G.
yes, yes,
So then calculate, we get answer.
yes. So there are two. Uh, we know the if you remember this equation, gamma bulk is equivalent to G gamma W
Answer
1 plus W
0.74.
divided by 1 plus E. If you remember this equation, you will remember every equation because then when I go to find gamma dry, I only need to take this as 0 and I will come up with G gamma W by 1 plus E. So if I so in this equation I know this value, I know this value, I know this value, this value. I can calculate from here itself, or an easier way and with less error will be to calculate from here because we know gamma d, g we know. So let us calculate from both from both equations and let us see how much difference we will get. We will get the same answer, but so how much was the gamma bulk? 19.18, I think, in the previous slide.
Yes, ma'am.
Okay, is equivalent to G is 2.72 into gamma W, we will take 9.81 into 1 plus 0.12 divided by 1 plus E, and E will be equivalent to from this uh, 1 plus E is equivalent to 2.72. Uh, is it 1.558? Two point.
My answer is 0.74 plus 1 transfer to other side.
Yes, but it will come out to be 55.8. Okay, let us calculate from here. Gamma D is
Ma'am, plus 1 transfer other side 0.558.
yes, I've written in percentage.
Okay, 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 ma'am.
Okay,
Okay, ma'am.
0.558,
55.8.
55.8%.
Okay, ma'am.
Okay. Okay, so gamma D was how much was gamma D? 17.125. Okay, so 17.125 equals 2.72 into 9.81 divided by 1 plus E. It should come out to be 2.72 into 9.81 divided by 17.125. Uh, it is coming out to be 55.8. E is coming out to be 55.8. Why don't you check your calculations if you have done any mistake anywhere?
Okay, ma'am. I will check.
Uh, one second.
Ma'am,
Yes,
if used gamma D equal to G gamma W 1 plus E, uh,
yes,
that answer 55.8% is
yes.
okay. But we use another formula, and gamma is equals to gamma W into G plus E into SR by 1 plus E. Okay,
Uh,
okay. No, ma'am. It's clear, clear. I got
okay.
some mistake. Okay, ma'am, clear.
Okay. So the answer for the second question is 55.8. Oh, sorry. Is so this is the solution for the second part. Okay.
Okay, ma'am.
So
Thank
let us
you.
move on to the next question.
Okay, ma'am.
Okay. So the dry density of a sand with porosity of 0.387. So the porosity,
Density.
uh, so the dry density is 1600 kg per meter cube. Find the specific gravity of solids. We have to find the GS and take the density of water equal to 1000 kg per meter cube. Okay. So you want to try this question?
Okay, ma'am. I will try.
So which formula will you use for this question?
Gamma D is equals to gamma W into G by 1 plus E, where we can find E is the void ratio, where E is equals to N by 1 minus N.
Yes. E equals N divided by 1 minus N. Okay. So E comes out to be 0.387 over 1 minus 0.387. This comes out to be 0.626.
Minus
Oh, sorry, I did a mistake in writing. 631. 0.631.
0.631.
Yeah, 0.631.
0.631.
Okay, so this is our E, and we know that uh, gamma D. So from here we can have G equals gamma D into 1 plus E divided by gamma W, and this will come out to be uh, this will be gamma D is 1600.
Where
1600
G is equals to 2.6096.
1 plus 0.631 over 1600 into 0.631. Yes, so G comes out to be
2.60.
2.609. Okay, so this is the solution for this question. Okay,
Ma'am, wait a minute. I've read the question.
yes, yes, please. But this will be available, uh, this video. This is getting captured and this will be available. But you can write, you can write.
Okay, okay, madam. Thank you.
No issue.
Completed, ma'am. Next
Okay,
question.
okay. So let's do the next question. One second. Has anybody joined? Okay, so some more people have joined. Chandan Kumar, welcome, welcome. We, if you missed something, I just want to recap that we are simply doing some questions based on assignment, based on the material covered in week one in this series. So in week one, you have just revised over the basics of soil mechanics, and we are trying to do these questions, and everybody's participation is appreciated. It is invited. And let us solve these questions together so you get more hold over the basics again. So if anybody who wants to join in with the discussions, they are more than welcome. Okay. Okay, so this is this is the third question that we are doing. The question says that the maximum and the minimum unit dry weights of sand are. So we have a gamma D max, 17.1 kilonewton per meter cube, and we have a gamma D min, 14.2 kilonewton per meter cube. Okay. The sand in the field has a relative density. So we have been given a relative density of 70% and with a moisture content of 8%, find the bulk unit weight of sand. So how will we do this? How will we proceed in this question? Anybody wants to join in the discussion how we should uh, move forward in this question? The concept behind live interaction sessions is that we have this brainstorming session where we can discuss with each other. If I am only I teach, it will be same as a lecture and it will not be that fruitful. I can do that also, but it would be very beneficial for you if you can join in on the discussions and we can come to a solution by together because this is just the beginning, but as the course moves forwards, things will get a little complicated, and this will inculcate um, the method of the thought train that you should have while solving these questions. Okay, Vanita, any suggestions on this? How we should do this? Chandan Kumar,
Yes, ma'am.
Uh, any suggestions how we should move on with this question?
Ma'am, your audio is not clear right now.
Hello,
Yes, ma'am. Yes.
is this better?
Yes, ma'am. It's audible now.
Okay. So any suggestions on how we should move forward in this question?
Suggestions. So, ma'am, we have a formula that formula of relative density from there, and water content is given. So, let me try once, then I will
Okay.
say.
So formula aside, let us try to understand what this question is. What relative density actually tells us? See, what relative density tells us is like if you have a material, especially a
Okay.
coarse grained material, the maximum density and the minimum density is an index property, which means that this will be, for example, if you are hauling a material in a truck, you have sand in this truck, and you're taking it to two sites. You're taking it to site A and you're taking it to site B. In site A, when you poured the material, you used rollers for compaction. Okay, so this will have a high density. But when in side B you poured the material, you just loosely left it there, you did not perform any compaction there. This will have a low density. See, the material is same in both cases. The density is different.
Sample is disturbed. That's the reason. That might be the reason.
No, no. It is that we have not put in any compactive effort here.
Oh,
Okay. So
okay.
what this says about a sample is there is a limit to the density in both sides. There is a gamma minimum and gamma maximum. There is a maximum limit above which you cannot compact it, and there is a minimum limit. No matter how loosely you pour, below this gamma, matlab it will, the grains, the lowest form the grains can take will be the gamma minimum, and the densest the grains can come to, it will be a gamma maximum. This will be an index property and it will be constant for a particular soil. And when you take this soil and compact it a little, not to the most extreme part, it will be somewhere here. This may be gamma natural. In its natural form, it is somewhere here. So the relative density basically tells you over the span that you have of the different uh, densities in which this soil can exist presently, in what state it is existing, because gamma natural can be very infinite number of values, but gamma minimum will be constant and gamma maximum will be constant, and these are determined in a laboratory. Sorry, laboratory. These are determined in, oh sorry, in a lab. Okay, so you take
Okay,
a
ma'am.
you take a sample, you take it to lab, you perform a vibratory table test in which you calculate the gamma minimum, you calculate the gamma maximum. So these are index properties, and then after this, in the field when you encounter this soil and you calculate its density, you perform a density test, its natural state. So you can compare it with its minimum, the minimum it can go, the maximum it can go, and then you can say, okay, this is relatively 78% dense, 78% of the maximum density it can achieve, or 90% of the maximum density the soil can achieve. So this is what is being asked. So this is what we mean by relative density. Uh, okay. 1 second. Okay. Okay. So now talking about the formula, relative density, as I showed you, that there is a minimum, there is a window in which gamma can exist, and then there is actually where the soil is existing. So if your formula is 1 by gamma natural minus 1 by gamma max divided by 1 by gamma minimum minus 1 by gamma maximum. It can also be written, if we take the, if we take the LCM of these terms, LCM of these terms, and this and this will cancel out, and we will get gamma maximum minus gamma natural divided by gamma maximum minus gamma minimum into gamma minimum divided by gamma natural. Okay, so why don't you put in these values in this equation and tell me, you already know the relative density, you know the uh, dry unit weights. Why don't you tell me the natural unit weight, how much it comes out to be? Okay, the relative density is 70%. Relative density is 70% is equivalent to 1 by gamma natural minus 1 by gamma maximum is 17.1 divided by 1. No, let us use the other formula. Gamma maximum minus gamma natural. It will be easier. Gamma maximum is 70.1 minus gamma natural over 17.1 minus 14.2 into gamma minimum 14.2 plus divided by gamma natural divided by gamma natural is 70%. It will be 0.70 equals 17.1 minus 14.2. 0.7 into 2.9 equals divided by 14.2 equals 17.1 minus gamma natural divided by gamma natural. Okay, 0.7 into 2.9, 14.2. So let me cross multiply first. Gamma natural divided by 17.1 minus gamma. Anybody got the solution?
I have this small doubt.
Yes, yes, please.
Yes. So where ID, the relative density is equals to gamma D minus gamma D minimum. So you are you are wrote the formula.
Uh,
Formula is I think little bit gamma D minus gamma D minimum by gamma D maximum minus gamma D minimum.
what is the formula? Yes, again, please.
Gamma D minus gamma D minimum by gamma D maximum minus gamma D minimum into gamma D maximum by gamma D into gamma D maximum by gamma D,
Hmm.
because
This?
relative density formula is equal to E max minus E by E max
Yes, yes.
minus E minimum.
Okay, okay, okay. Let me see, let me see. Gamma. Okay, then I have taken the numerator. I may not have taken correct. Okay. So the numerator will be, actually what I have to do is I have to take 1 minus this. 1 minus this. This will be ID, na? 1 minus whatever I had taken, we will get this. As I said, So what we are calculating from here. I was calculating from here. Okay. So what I have to do is 1 by gamma no, minimum minus 1 by gamma natural. Gamma minimum is here because gamma minimum is smaller and then the inverse will be greater. So we will not have a negative number here. Uh, so if I calculate this, I had written in the numerator 1 by gamma natural minus 1 by gamma maximum divided by 1 by gamma minimum minus 1 by gamma maximum. If I take 1 minus this, I will get this thing. So basically the concept is same, but here I was approaching from the gamma minimum end, and in this formula we have to approach from the gamma maximum end. Thank you very much. Thank you, Vanita. Okay, so here you want me to do this again, or you have this formula? Let us. Okay, so this is our relative density. So anybody got the answer for gamma natural?
Ma'am, 15.28.
15.28. Okay, and one second. Uh, it will be 16.11 actually. Let's calculate it together. Okay. Uh,
Okay, ma'am.
let's let's see if there is an error. Here I will write gamma natural minus 14.2. Okay. Here this will be 17.1. Did you get the solution, Vanita? Okay. So this will be 17.1 minus 14.2 is 2.9. Uh, Gamma natural into 0.7 into 2.9 equals
7.8 అలా వస్తుంది.
huh?
ఇప్పుడు కొంచెం నీట్గా వేయను.
0
1 divided by gamma d minimum
2.9 divided by
14.2.
14.2 కరెక్ట్.
0.070 కదా.
ఇది 580 రా.
equals
కరెక్ట్.
అంటే
1 మినిట్.
8.4 వస్తుంది. తప్పు చేశాను.
కరెక్టే రా. 8.4 అంటే 0.3.
Zero point one two.
ఎంత వచ్చింది? ఇంటూ 10 to the power of
Yes, ma'am. 16.28.
So gamma nat will be
0.06.
Vanita.
Yes, ma'am.
Can you mute
16
until you
point
find? Okay, okay,
gamma d is equal to 16.23.
okay. Okay. Okay, so this is the gamma D. So how do we find the bulk unit weight?
Where gamma D is equals to gamma by 1 plus W.
Yes. Gamma bulk is equivalent to gamma D into 1 plus W. This will be gamma bulk is equivalent to 16.23 into 1 plus
Intercontinent
0.08.
at 0.08.
So the answer will be, what will be the answer? 16.23 into
17.53.
1.08. Yes, 17.53. So this is the answer to this question. So okay. So let's move on to the next question.
Okay, ma'am.
Okay, this is a very straightforward question. If the effective angle of internal friction of a soil is 10 degrees, that is phi equals, sorry, let me write it in a better way. Uh, Phi equals 10 degrees. Find the angle between the failure plane and the major principal plane. Okay, so any suggestions on how we do this question?
45 plus pi by 2.
Yes, that is correct. So theta is 45 plus pi by 2. Just to give a visual explanation, in geotechnical engineering, when we draw the Moore diagram, we have the normal stress here, we have the shear stress here, we have the sigma 3. We take this as sigma 1 and we take a circle. One second. Uh, okay, so here where our envelope is formed, this tangentially, it meets tangentially here, this will be the failure point, and we join this, and as you know, tangent to a circle is always 90 degrees. This angle will be 2 times theta, and theta is our inclination to our failure plane. Okay, this is uh, this is our failure plane. This is, one second, please. One second, please. Um, Abba, class, class, class. Okay, so this is the angle that we are talking about. This we have to calculate, and in the Mohr circle diagram, this is equal to 2 theta, and as you know, this is our phi. And if we take this is an external angle, you know that external angle is equivalent to, sorry, sum of two opposite internal angles. So this will be equivalent to 90 plus phi. 2 theta equals 90 plus phi, and theta will be equivalent to 45 plus pi by 2. So here our theta will be equivalent to 45 plus 10 by 2, and theta will be equivalent to 45 plus 5 will be 50 degrees. So this is the answer to the question. Okay, everybody got it? Everybody got it?
Yes, ma'am.
Okay, if you have any doubt, you can always mention. Okay, okay. Let us do the next one. Shall we move on to the next question? Okay. So, in a laboratory consolidation test, the void ratio of sample reduced from, uh, so we have the void ratio and the pressure. Let me draw a graph. Okay, so the void ratio is here, pressure is here. Void ratio reduced from 0.85 to 0.73 as the pressure increased from 1 to 2 kg per centimeter square. Okay, so we have to find the coefficient of volume change for soil. Okay, so what will be the answer? What is the coefficient of volume change? Any answer?
where mv is equals to delta E by 1 plus E in E naught into delta sigma effective. Delta, sorry, delta
Div-
sigma.
Divided by delta sigma, I think. As far as I remember, it used to be divided by delta sigma, delta E by delta sigma. Is that it? Is this the correct
Yes, ma'am.
formula? Is this the correct formula?
1 plus E naught.
Hmm. AV used to be delta E over delta sigma, and MV used to be AV over 1 plus E naught. Is it? Okay, so can we calculate this?
Calci.
Delta is 0.85
Where is
minus.
calci?
Okay, so why don't you calculate it, Chandan?
Yes, ma'am.
Yes, what will be the answer?
Answer, ma'am. Just a
Yes,
0.06.
0.06. Yes, 0.65. Yes, that will be the answer. And what will be the units?
Centimeter square per kg.
mm,
Kg per centimeter square. Centimeter square per centimeter square per kg. Yes.
Reverse. Centimeter square per kg.
So this will be the answer. This will be the answer to the question. Okay. So next question. Shall we move on to the next question? Uh, shall we move on to the next question?
Okay, ma'am.
Okay. So this is about the vein shear test. So we have a vein which is 18 centimeter long and 10 centimeter in diameter. Okay. Pressed fully into soft marine clay. Why does it say fully into pressed fully? Any idea? Any idea? That is because the depth of penetration of the vein will determine if both of the edges of the vein are to be considered or not. Here, since the penetration is complete, both edges will be taken. If it was partially penetrated, this edge, the shear resistance of this edge would not have been taken into account in calculation of the formula. Okay, so the torque was applied to the vane gradually until a failure at torque at failure is 995 kg centimeter. Okay, so what is the cohesion of the clay? So how do we solve this? How do we solve this, guys? Okay, one second, just let me. Yes, okay. We know that cohesion will be equivalent to the for both the faces taking part in shear resistance. Torque will be the cohesion will be equivalent to torque divided by pi d square h by 2 d by 6. This will be equivalent to 995 over pi 10 square 18 by 2 10 by 6. How much will this be? This will be equivalent to 0.297 kg per centimeter square. This will be the answer. So these were the questions that I had planned for today. So anybody has any questions about these questions that were discussed today? Let me recap. We did a question. These are all basic soil mechanics problems. We did a question on the moist, on the basic soil volume weight relationships. This again is volume weight relationships. We did a question on this again is volume relationships. Then this is on the relative density or the index properties. Uh, then this is for the shear strength. This is from the shear strength part. This is from the compressibility, soil compressibility part. This is from the shear strength part. So, any questions for questions discussed today? Okay, I think we have another half an hour. So, we will be discussing the assignment 0 after this. But first, let us take a 5-minute break. Okay,
Okay, ma'am.
we will read. We will be in the meeting only. Let us regroup at 7:35.